Come on. Come on. You can do it. Right. Work. Okay, so write that down. Everybody looks cold.
Yes. You should turn it off.
You want it on?
Yes. Why you don't want on?
Because it's not cold.
Because it's close to the heat. Because you are Irish.
Yes, I am an Irish person. I'm a dice. It gets cold in China, doesn't it?
Yes. But
Yeah.
in my city, no very
Oh, you have a hot city, yeah?
Yeah, but in my city it's very cold.
Very cold. So this is normal for you.
Nah, no. I don't want.
You don't want it? Okay.
I want some warmer place.
Warmer place. You should visit their countries though. Yeah. Malaysia's pretty warm in the summer, isn't it? And you're from Pakistan. That gets pretty warm as well. Oh, yeah.
Not that warm.
Not that warm. Okay. All right. Now work. Okay. Right. So this picture here, the man is doing work is being done. Of course, you can see him doing work. So what do you need to have work? I mean, if you look at this picture, why are you saying there's work being done?
Force and distance.
Yeah, no, but what do you need in the picture? You need a force.
Energy.
Energy.
Power.
We haven't done energy yet, but good. Power, yes, we haven't done. But we all see that you need a force. Yeah, and you need a distance as well.
Yeah.
You know, he's moving something. There's a force and there's a distance.
Push or pull.
So there's a force. The man is shoveling. The force is making something move, isn't it? The sand is being moved. And there's a displacement. It's being moved somewhere, a distance. So the sand moves with the shovel. Anyways, we all got the idea here.
Shovel.
Shovel? This is shovel. I'll draw it. No, hang on, I can draw a shovel. And then you use it to dig a hole.
Okay.
Yeah?
Yes.
Yeah.
Something.
And then
Fly.
people you don't like, you can put in the hole. And then you can put the sand back on the hole. We understand?
Yes.
Yeah. So this is
Very easy.
very clear. What? What?
No, don't let teachers know.
Don't let teacher know. Okay, don't tell me. I don't want to know then. Right. No. Don't.
Wait, a little bit. 10 seconds.
10 seconds? They're saying something bad, I know. Jonathan?
Finish.
I wish somebody else spoke Chinese. I feel like that was really bad.
No, not that bad. Just little bad.
Just a little bad. Alright, okay. Right. And finally, the force is usually over an area. So, for example, you know, if I was lifting this up, there's a force, there's a distance, and also on my hand, you know, there's an area. Yeah. Okay. So, let's have a look here. So definition, what exactly do we mean when we say work in physics? So when we say work done by a force,
English?
This is English, not Chinese. What are you asking me? Usually, yes. On a body is the force along the direction of the displacement multiplied by the displacement of the point of application. Very complicated, but as a formula, very simple. A formula is just work is force multiplied distance. Where W is work, F is force, and S is the displacement. So write this down. The formula is what's most important, but to practice your English, maybe you could write the whole thing. Some students need to practice their English.
Yes, some students.
Some students. Not you.
Yes.
Some students just. Like the students behind you. Yeah? Force
Oh yeah, yeah.
multiplied by displacement, yeah. Yeah? We got this? So, what is the unit for F?
Newton.
Newton.
What, I shouldn't have said what are the units for F?
Meter.
Meters. So therefore, the units for work is what?
Newton meter.
Newton meter. Now, we call the units joules, but please note that joules is the same as a Newton meter. Okay, so 1 joule is 1 Newton meter. So 1 joule of work is done when 1 Newton of force displaces an object by 1 meter. So in other words, 1 joule is the same as 1 Newton meter. They're the same thing. Too much English. Not enough Chinese. English 100%, Chinese 0%. Chinese nearly 0%.
Everything.
You probably speak no English in your home, right?
Yes, of
Yes,
course.
of course. This is good for you, right? Oh, is your mother here?
No, this evening.
This evening? Ah, okay.
I will not bring her here.
Are you sure?
Pretty sure.
She can meet all your friends.
Ah.
Maybe I'll go to your homestay, say
Okay.
hello.
Okay.
Is she? No, she's not staying in the homestay, is
Yes.
she? She is staying. Perfect. I'll get the address from Sylvia.
Mhm.
All right. You have this? Yes.
My mother will kill me.
Yes.
Never see me again.
Yes.
Bye
Yes.
bye, Steven.
That's right.
I
That's
was
right.
a good girl.
You were a good girl. Now you're dead.
No, yes.
Yeah. Like the picture.
Yes, but I'm opposite. Yes.
Yes.
You are good.
Yes. I think. Well then.
If you tell my mother something
Oh,
good.
it'll be like this. Yes.
Yes.
Yes. Okay. This is me. Yeah. All right. Okay. Next now. So let's have a look. You don't need to write these down. These are just to get you thinking. So in each example, I want to know what is the work being done. So a mother lifting her baby up from the ground. So what work is being done? Well, if we just have a look at the picture here. Yeah, go to that picture. And here's the baby. Beagle baby. Yes. She is lifting the baby up. So there's a force F going up, and there's a distance S. So it's clear here, the work being done. A woman pushing a large box across the ground. So she's pushing this box. So again, there's a force and there's a distance. Yeah, so far? Okay. A man kicking a football. Now, what about this? So a man kicking a football.
Long leg.
So what's the force here?
Pulling.
Yeah,
Ankle.
but it's only the force while his foot is touching the ball,
And the distance
and
is from his leg, the leg from the beginning touching until he touches the
yeah,
ball.
it's the distance
Very short.
for the shot, but it's quite small, you know. Okay. A child hitting the wall.
There's no work done, right? Is there?
There's no distance.
Yeah.
Well, nice
The
is.
ball going back.
Yeah. Depends how strong the child is, doesn't it?
To punch.
Yeah.
In the end of the punch.
and that hand is broken. Yes. Well, there's definitely a force, isn't there?
Yeah. Yes.
The distance is.
Very short.
Yeah, the distance is not so clear, but it's a very short distance. Yeah, well, what's happening is, his hand, okay? If you watch the video, his hand hits the wall, the distance is like maybe 1 or 2 millimeters as the hand kind of, compresses. You know what I mean? Like it gets, the distance is very small and then it goes back to normal.
So if the hand is have more meat touch with
More fat.
more fat.
More fat.
More meat.
Um,
More fat.
yes, of course, because think about it.
More fat.
More fat.
Will touch. The distance will be
The
longer.
distance will be longer. Yes.
Mm.
Yeah. So fat hands, more work. Yeah. Yeah. Now, of course, it's not really, the type of problem we do because this distance is so small. It's so small. Okay. So if you want, you can say it's no work because the distance is nearly zero. Yep. And the last one, a father carrying his child.
I think there is no word there.
Again, this is one of the complicated ones because the father and then the child, baby again. Now, yes, butter, yeah. The father is given a force up, but what's the distance? Imagine the father's moving this way. The distance is here, isn't it? But you don't use that distance. In your formula, you use the distance in the direction of the force. So do you see here, look, the distance and the force are always in the same direction. But here, the distance and the force are in different directions. So you don't use this one. But you might say here there's no work. And that's right. We don't really say the father is doing work here. The father did work to move the boy up here, but once the boy is on his shoulders, he's not doing any more work. Now, you and I both know that's not true because it feels heavy for him. So there is a little bit of work being done because the boy's height is changing as he walks. Because he's moving, there's a small distance as he walks. He's not walking perfectly level. So there is a small distance here. And each time he goes down and up a little bit as he walks. That's some work being done. Yeah. Uh-oh. That doesn't sound good. Oh, no, it's okay. Okay, are we okay with the idea here? Yep. Alright.
So the force and distance is always
Yes. Yes. So the important thing here is if there's a force, you only count the distance it moved in the direction of the force. Yes. Yes, the same way for the distance. Yeah. So for example, look, if you have a force this way, but it moves along the ground like this, you don't use this force. You must use this force.
We use the force and same with the distance.
Yes. Got that?
Yeah.
Good. Okay. And maybe you want to make some note about that, about the distance. My beautiful picture. This. Okay.
Beautiful.
Yeah. A double star. Okay. So he, no hot chocolate today?
Kit Kat.
No Starbucks hot chocolate? No. No money?
No, I want Christmas gifts.
Oh, it's the offer.
Yeah.
Special deal, yes, yes. Okay, continue. Right, so the last example was interesting and we talked about it. So, yes, we did have a conversation about that. So let's see, how many questions do I have? Hold on, hold. Maybe there's only 2 questions. Let me just check. Ballerina, definition. I think I only have 2 questions. Good, okay. Right. Okay, this question please. Ballerinas are good examples for physics because they've got, they're turning, you've got pressure, you've got, remember center of gravity, got everything. Got it? Not everybody. You're finished first. Congratulations.
Because I'm making the main name shorter.
That's good though. That's good. Okay. Yes?
Okay.
Yes? Okay. So So, a woman pushes a 100 kilogram box along a smooth surface by applying a force. The block starts at rest and reaches 1 meter per second over 5 seconds. So, what we have here is the box. It's 100 kilograms. And then there's a force here. And the box goes from 0 meters per second, and then it's at 1 meter per second, and it takes it 5 seconds to do this. So it starts at rest, and then she pushes. Okay. U, V, A, T, S. The first part is, what is the A?
1 minus 0 times.
Yeah, well, let's write down the info. U, 0, V, 1, A, don't know, T, 5, S, don't know. So we can say V equals U plus AT, and we'll get our first answer. A is 0.2 meters per second squared. The first answer. Yeah. Next question is, what is the distance the block travelled? So what is the S? What formula? Let's use S equals UT plus a half AT squared. That's 0, a half AT squared. That would be 0.1 is a half A times 25. So that's 2.5 meters. That's the S. Yeah? Yes? Yes. Okay, next, what is the force? So what formula can give us the force? F equals ma. That's equal to 100 times 0.2, which is 20. 20 newtons. So the last part you can probably guess is the work. Well, not last part yet. Work is force multiplied distance, which is 20 multiplied 2.5, which is 70 newtons. No, 50 newtons. 50 joules. Newton meters, yes, thank you. Okay, last part is, if the same force was applied at an angle of 10, then how much work was done by the block? So, can I go down a bit? Yeah, so what's different this time is that she puts it at an angle of 10 degrees. So it's still the same force. What would I get as the force? 20 newtons. But this time now it's only 20 cos 10. So if you put that instead of F, your work will be a little different. 20 cos 10 times, it's still the same distance. What was the distance? 2.5?
Yeah.
49.2 joules. Now this is where it gets a little bit complicated. Do you think the woman did more or less work when she's pushing at an angle?
Less.
Maybe less? It looks like less, doesn't it?
I think she did more.
But maybe she did more. Well, through her point of view, what's her force? It's still 50, isn't it?
Yeah.
So she's just pushing at an angle. So she's still doing the same amount of force, but the work, the block done is less. So what's happening here, which is more about the next lesson, is some of the energy she has is not all being used to move the block. So it's like some of the energy is wasted. So the block did 49.2 joules of work, but the woman, she probably did more than this. So some of the energy was lost. And you think about it, it makes sense, you know. If I want to move this from here to here, I should push it straight. If I push it at an angle, less work is being done here, but I'm still doing the same work. I'm wasting energy, you know. Anyway, that's more about the next lesson. Don't worry about that yet. Okay, continue. Yep. Right, so now ballerina time soon. So there's another element here. Why does standing on one foot feel more difficult? So you think about it, if you're standing on two feet, it's still mg, but if you're standing on, no, don't make them taller. If you're standing on one foot, it's still mg, but it feels harder. It feels like more force.
Because they are moving more.
No, because the difference is the area here is twice as big as the area here. This is what makes it feel more difficult. So, like with the ballerina, it's more difficult on one than two. I think there's something cut off here at the bottom. Anyways, this gives us the idea of pressure. Pressure is how much something is pushing on something else. But really that's a terrible definition. Don't write that down, just write the formula down. Pressure is force over area. P is pressure, F is force, and A is area. Yeah, pressure is when you push. And look, here is pressure, and here is twice the pressure. There's,
You mean the force going down?
it's the force and the area. You translate it?
Yeah,
Okay.
yeah.
You understand?
Yes.
Okay. Pressure. Force per area. Now, what's the unit for force? Newton. And area? Meter squared. So what's the unit for pressure?
Newton meter minus
No, try that again. No, try that again.
Newton meter minus
Newton per meter squared. You said force. Yeah. So the unit is Newton per meter squared. Let's see, show me. Yeah? No. Minus 2. You divide it. Minus 2. Yes. Now it's right. Yes? Now, we use something called a Pascal, but a Pascal is the same as Newton per meter squared. So 1 Pascal is 1 Newton of force at right angles over 1. Now, that's a little mistake. There should not be a minus here in my definition, okay? I need to fix that. It's 1 Newton per meter squared. Anyways, and see, I haven't. Wait. I'll fix it now. Let me just fix it. 1 second. Right, sorry. It should be. There's no minus on the first one, but there is a minus on the second one. I have it backwards. Yes? No, we'll finish earlier.
Go on, go on. Continue.
I'm waiting for this to finish.
Yeah, I really need to.
Wait. A few more seconds. There we go. Okay. Now it's fixed. Just one question, and then I can give you the homework, and then we can start the next lesson.
Okay.
Right, so now it's fixed. There we go. Okay, so now get definition for a Pascal. It's the same as 1 Newton per meter squared. Please write this definition down. You sometimes have it in the exam. Did you write this definition down for Pascal?
No. What?
Did you write this definition down for Pascal? That's no, is it?
I wrote 1 pi equals 1 and
N minus 2. Okay. No, wait, Grace. If you wrote that down and you can explain that in words.
No.
Okay.
So what is meant by this right angle?
Yeah, when we talk about pressure, we always talk about the force and the area to be perpendicular.
Oh. Doesn't work, they are parallel and here they are perpendicular. Say solve.
No, in words, the force and the distance are parallel, but the area we haven't done yet, it'll still be perpendicular. We'll see in the next example. Yep. Okay. Let's have a look at an example. So, basically, this example continues from the last example, except this time I say our hands are 100 centimeters squared. So, we'll just continue with the last example. Where is she gone? Here she is. But this time, the area here, oh, terrible. We want the pressure at this area. To the right, to the left.
what is
The question says her hand has area of 100 centimeters squared. So, 1, 2, 3, so that's a hand. And its area is 100 centimeters squared.
what
What
is pressure?
is the pressure on her hand?
Oh my god, that is huge.
No, it's not really. I don't think so.
Then,
10 by 10.
yeah. What's the question again?
What is the pressure?
Okay.
Okay, so what's the formula for pressure?
F over
Force
area.
over area. Now what's the force here? What did we say it was previously?
20.
20 newtons?
Really?
Yeah.
Not in angle.
Huh?
In angle?
The force. No, the force, it's still 20 newtons. Yeah. Oh, I see what you mean. Yeah, it's the one. No, no, not at an angle, just horizontal, not this one. Yeah. Okay. At least I think that's what I said. Yeah, yeah, no angle. Okay, over the area. Now, is the area 100? No, it's not, because that's centimeter squared. We need to convert it. 100 centimeters squared equals 110 to the minus 2 meters squared, which equals it's going to be pretty small, 0.01 meters squared. Is that right? Wait, I left out one thing on purpose. I forgot something here. What did I forget?
Unit.
Newton.
No, 20 newtons, yes. This is the area.
2 hands. 1 hand.
Yes, 2 hands. Area is twice as big. Yeah, so I'm sneaky like that. So the pressure is 1000 pascals. Or if you want, it's 1 kilopascal. Mm-hmm. Pressure.
No, no, it's always 2 hands.
Sure.
Did you say it's 2 hands?
Well, let's see what I said.
No.
In her hands?
Okay, okay.
Not her hand.
It's capital letter of K or
Small k.
small k.
Yeah.
So what's the big K? Kelvin?
Kelvin, yeah. We don't actually use it as a prefix. Okay, do you have this?
Yes.
Yep. Alright. So, here are your questions.
Can we just do one homework for this evening?
Yes.
It's Chinese New Year.
Yes.
In China this week we
We have
usually stay at
holiday.
I
home.
know. I'm so sorry. Next week is your holiday.
Yeah.
Yeah. Okay.
I don't
What?
only 5 minutes.
5 minutes. Okay. Be quicker than 5 minutes, please. Because I still have the other lesson to do. Also, question 4. What did you forget, Fahad? They're yours.
I have.
Oh my goodness. You remember Fahad, don't you? Yeah. No. No. I was just saying, question 4. Try your best. Maybe I'll delete it. It's very difficult, but try your best. Definitely do 1, 2, and 3. Yeah. All right. Did you take the picture?
Yeah.
Yes. Okay. Closing.